going to do is go through an example or two of graphing rational functions for you. And these are when you have a polynomial. This is a polynomial divided by another polynomial. This is kind of what I refers to as the harder ones, because in these examples we don't have vertex form. Remember, if it was y equals a divided by x minus h plus k, then we could move it around, right? We could move the basic shape of a rational function around based on the values of h and k. But we don't have that in this example, so we can't just do that. I'm making a video, so what we're trying to do here is to graph this having a polynomial divided by a polynomial. And we have to follow a set of steps. All right, so in the steps, the first thing we want to do is check to see if both the numerator and the denominator are factored. That's our first thing we have to check. And yes, these are factored. I can't do anything to those. If I had something like y equals 2 divided by x squared minus 4, well then I could factor that denominator. And I would want to do that before I go on. But maybe we'll come back and look at that example later. So first check to be factored. So in this example we have right here 2x plus 3 divided by x minus 5. We can say that's done. Those are factored. All right, so step 2. Step 2 is look for holes. All right, now how do I know that a hole is occurring? A hole is occurring when there's a common factor in the numerator and the denominator. So if I had something like y equals x minus 2 divided by x squared minus 4, well, I can simplify that to be x plus 2 times x minus 2, so I factored it, and that common factor would cancel out. So this simplifies down to just 1 over x plus 2. But because we can't have zeros in the denominator, I still have to say x cannot equal 2. Right? That factor that I canceled out, that would be a hole. So I have to look for those and I write them down. But in this example we're looking at right here, I have no common factors, so I have no holes. So I would say to myself, no holes. All right, that's going to help me. And holes, we're going to use in our graph, we're going to use little circles. But I don't need to do that because there's no holes, but I'm making this checklist so as you graph other ones you can. So step 3, look for vertical asymptotes. So once we've canceled out any holes we have, vertical asymptotes occur where the denominator equals 0, but after we got rid of the holes. So after we have the holes, what will make the denominator equal 0? Well, denominator equals 0 will cause vertical asymptotes. So here, if x minus 5 equals 0, that means that x equals 5. And so this is where the vertical asymptote occurs, right? Because I can't have that 0 in the denominator. So let's try to have space to graph this. I can tell myself right now, on my little grid here, that, and I show this with a dotted line. So 1, 2, 3, 4, 5, where x equals 5, I want to put on that vertical asymptote. So I know my graph is not going to touch that line. All right, step 4. So we could put our little check there. We did. We checked for vertical asymptotes. So step 4 is I'm going to find my horizontal asymptotes. All right, so horizontal asymptotes. I put my pen in my mouth. We have some rules for horizontal asymptotes. So what are those rules for horizontal asymptotes? We know they're going to occur based on the degree of the numerator and the degree of the denominator. So in our numerator, so here we have to look at, let's maybe make this orange. We have to look at the degree of the numerator, and we have to look at the degree of the denominator. And remember, that's the highest power of x. So in the numerator, I have a degree of 1. And in the denominator, I have a degree of 1. And we use the letters n and m. So we use the letter n for the degree of the numerator, and we use the letter n for the bottom, the degree of the denominator. So in terms of our horizontal asymptotes, we have n equals 1, and we have m equals 1. They're both 1. And now, well, what are the rules? Well, when the degree of the numerator is the same as the degree of the denominator, then we have to look at their leading coefficients. So we say that the horizontal asymptote, that's the y equals parts, equals in this case, so y equals, we look at the coefficient, equals 2. The coefficient here, even though we don't see it, is 1. So our horizontal asymptote is going to be here at y equals 2. But we don't always have the degree of the numerator the same as the degree of the denominator. So when the degree of the numerator is less than the degree of the denominator, then we always is going to be y equals 0 is going to be our asymptote. And when the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. All right, so you got to put these rules in there someplace so you have them. All right, so now we know our horizontal asymptote. Step 5. Well, what is step 5? What's going to help me next? If I know where the graph crosses the x-axis, that's kind of helpful. So we call that the X-Intercept. So what is the X-Intercept? Well, that's when y equals 0. So we'll make this step in blue. So if I set y equals 0, I have 0 equals 2x plus 3 divided by x minus 5. And I really have a fraction equaling a fraction, right? It's weird writing it 0 over 1, but it's what I have. So when I cross multiply these guys, I end up with x minus 5 times 0. It means I have 0 equals 2x plus 3. So we can see it's always going to work out that finding the x-intercept is when the numerator, whatever's in the numerator, equals 0. So this is going to be, x is going to equal, subtract 3 from both sides, divide by 2, is going to be negative 3/2, which is the same as about negative 1.5. So I know that this is going to cross the x-axis here. That's pretty useful. All right, last step, well, not last, second to last step, is the y-intercept, right? If we know where this graph crosses the y-axis, then that's also going to be helpful. I'm going to give myself a little bit more space, so I'm going to erase the x-intercept. Can do red for the y-intercept. Well, that means that x is going to equal 0, right? The intercept is on the place where x equals 0. So y equals 2 times 0 plus 3 divided by 0 minus 5. 2 times 0 is 0, so that's going to be 3 over negative 5. So negative 3/5, it's a little bit more than negative half, so it's going to cross like this. All right, and the last step, I'm kind of running out of space. This screen doesn't let me slide. The last one, I'll try to fit it down here, is slightly use a table of values. And you could even put this in the calculator, or you can use the shape of the graph. I know that this graph cannot go above this horizontal asymptote, and I know it's approaching here. So if I want to kind of look at where this graph is growing, I know it's not going above. I know it's crossing here and here, and I know it's going down along this asymptote. All right, and then they're very symmetrical, right? Like when you've done rational functions, it was here and here, or here and here. So we can use this other asymptote. It's going to be here and here. Now, the table of values part is that if I wanted to know exactly where it was, well, here's 5. Here's x is 5. So if I went to, like, let's say x was 10, right? If I put x in 10, 2 times 10 is 20, plus 3 is 23, and then 10 minus 5 is 5. So that is almost, right? When it's 10, it's almost 5. Not quite. They have to be 25. So when x is 10, let's make it black. So that's 6, 7, 8, 9, 10. Then y was almost 5. 2, 3, 4, 5. And that's not bad, right? I need to fix this a little bit. And that's why a table of values, sorry, not drawn very well. A table of values is going to help you figure out exactly how those curves go. All right, so is it factored? Look for holes. Look for the vertical asymptote. Look for the horizontal asymptote. You got to have the degree of the numerator and the degree of the denominator. Find the x-intercept, find the y-intercept, and use a table of values. I'm going to send this first, and then I'd like for you to send me what you're working on so I can see your work, and if I need to, I can make a few more videos for you.